So let's look at determining the units of the rate constant k for the integrated rate laws. So for our first order integrated rate law, we've got our equation written here. And what I'm going to do is isolate our rate constant k and basically just get it on one side of the equation, which means I'm going to divide both sides of this equation by t. So we'll have natural log of the concentration of A at times t divided by natural log of the concentration of A at times 0, all divided by t is equal to minus k. Sorry, there should have been a negative sign there. And so our units then, we can just plug into this equation and see what we end up with. So we are going to have for concentrations, we're going to assume we're using moles per liter. And so we'll have moles per liter divided by moles per liter for our concentrations. It doesn't have to be moles per liter, but oftentimes that's what we will end up using. And then time, let's say that's measured in seconds. Okay, and this is all equal to minus k. Moles per liter divided by moles per liter is 1. And so we're left with 1 over S is equal to minus k. And so the units on the rate constant for a first order reaction are going to be equal to 1 over S, or you might see it as written as S to the minus 1. Okay, so we can do the same thing for our second order integrated rate law. We'll plug in the units for concentration and for time. And again, we're going to use moles per liter for concentration and seconds for time. So let's first isolate k on one side of the equation. So we'll have 1 over A at time t minus 1 over A, concentration of A at time 0. And we're going to divide that by t, and that's going to be equal to k. All right, so let's plug in our units now. We'll have 1 over moles per liter minus 1 over moles per liter divided by our seconds equals k. 1 minus moles per liter, 1 over moles per liter minus 1 over moles per liter is still 1 over moles per liter. And all of that's still divided by S. And we can rearrange this to make it a little bit more user-friendly, in that this is equal to liters per mole times seconds. So that's for a second order reaction. Okay, so continuing on then with zero order, we're going to isolate k, so we're going to have A at time t minus A at time 0 is equal to minus k times t. Divide both sides by t. Okay, set everything equal to minus k. Alright, so we'll plug in our units. We'll have moles per liter minus moles per liter over seconds. So that will end up with moles per liter over seconds. And to make that a little bit more user-friendly, we'll just basically divide out the per seconds and say moles per liter seconds for our units on K for a zero order reaction. So if you are given the units for an integrated rate law, you should be able to determine if a reaction is first order, second order, or zero order.